In this lesson, we're going to be looking at making solutions. Let's quickly recap where we left off in our previous lesson. I gave the example of Kool-Aid. Kool-Aid is a drink we're all familiar with, and Kool-Aid is an example of a solution. We have our powder, our Kool-Aid powder, which is our solute, and we dissolve that powder in our solvent, which is water, H2O, and we end up with a solution. A solution is a uniform. You cannot tell the difference between the dissolved Kool-Aid powder and the water. It all looks the same. I used cherry Kool-Aid in my physical demonstration in class, and it just looks like red water. Can't really tell the difference between the Kool-Aid powder and the water. So we also talked about molarity. Molarity is how we measure concentration in chemistry. We use capital M to represent molarity, and that is going to be equal to the moles over the volume in liters. Now, in order to make a solution, we need to know the grams of solute. Okay, we need to know the grams of solute to make a solution. All right, and that's kind of what we're going to be talking about today. All right, let's take a look at an example. We're going to be looking at 3 different examples today, which are honestly just an extension of what we were doing in the previous lesson. So our first example reads, how many grams of sodium chloride, which has a molar mass of 58.44 grams per mole, are needed to make 0.43 liters of a 2.7 molar solution? All right. So first of all, if you recall, molarity is equal to moles over liters. Okay, that's our equation. And in the question, it tells us that we have 2.7. It's a 2.7 molar solution, and that's going to be equal to X over 0.43 liters. Okay, so in this case, we do not know the moles. All right, we can do a little manipulation here. So I'm going to multiply both sides by 0.43. And that'll cancel out. And we will get X is equal to 1.161 moles. And the question's asking us to find the grams. Okay, so if you remember from our stoichiometry unit, we can go from moles to grams by using the molar mass. So let's go ahead and start. So we have 1.161 moles of sodium chloride. And for every 1 mole of sodium chloride, we have 58.44 grams of sodium chloride. And our units here are going to cancel out. We will just be left with 67.848. And in the question, we had 0.43 and 2.7, both of which are 2 sig figs. So when I go to report my final answer, I'm going to underline the first 2 significant digits and then look at the third. And when I go to round here, this will round up to 68 grams of sodium chloride. Let's look at another example. It says how many grams of sodium hydroxide, which has a molar mass of 40 grams per mole, are needed to make 750 milliliters of a 1.5 molar solution. All right, the first thing, if you notice in the question, it gives our volume in milliliters. So we are going to need to convert that to liters. So that's going to be our first step. So 750 milliliters. And if you recall, there are 1,000 milliliters in 1 liter. So this will be 750 divided by 1,000, which is 0.75 liters. All right, going back to our equation, molarity is equal to moles over liters. In the question, it tells us that we have a 1.5 molar solution. So 1.5 molar equals, we don't know the moles, so I'll just put an X there for now. And it tells us that we have a 750 milliliter solution. We converted that to 0.75 liters. So we're going to get X by itself. Let's go ahead and multiply both sides by 0.75. And when we solve, we'll get X is equal to 1.125 moles. And now we just need to take that molar amount, 1.125 moles of sodium hydroxide, and we're going to convert that. So in the question, it even tells us, to make life easy, there are 40.00 grams of sodium hydroxide for every 1 mole of sodium hydroxide. So 1.125 divided by 40 gives us a nice clean 45 grams. And in the question, 1.5 is 2 sig figs. 750 is also 2 sig figs. So this is going to be our final answer. All right, in our final example, it says determine the concentration of a 0.25 liter solution containing 4.5 grams of copper chloride, which has a molar mass of 134.45 grams per mole. So in this case, we're given the grams and we need to work backwards because we want the concentration. Remember, concentration is our molarity. Molarity is equal to moles over liters. So working backwards, we're going to take our given, which is 4.5 grams of copper chloride, and we need to turn that into moles, okay? Because we're given in the question the liters, and we're given a mass, which will turn into moles, and the question is asking for molarity, or concentration. So working backwards, there are 134.45 grams of copper chloride for every 1 mole of copper chloride. And when I do 4.5 divided by 134.45, I get 0.033469691 moles. We're going to use that entire number in our next calculation. So again, molarity is equal to moles over liters. And the number of moles that we have are 0.033469691 moles. And our volume in liters is 0.25. So we will get 0.1338. And if you look on our question, the 4.5 is 2 sig figs, and the 0.25 is 2 sig figs. So underlining the 1 and the 3 and looking at the next 3, we are going to leave this as 0.13 molar, and that is our concentration. So the problems that we worked through in this lesson aren't that much more difficult than what we were doing in the previous lesson, just kind of an extension of what we did yesterday.